Okay, welcome back to the last video of Chapter 2. Now that we've covered moles and so on, we're going to talk about how to find empirical and molecular formulas just from raw data. So here is how you go from mass percent to empirical formula. Now remember that finding an empirical formula starts by burning a compound and collecting the ashes. That gives you the percent by mass of each of the elements in the compound. So, for this example, our compound is made of 3 elements: carbon, hydrogen, and oxygen. It is 40.002% carbon, 6.7142% hydrogen, and 53.2838% oxygen. So, here's how we go about finding the empirical formula from those numbers. First, we just convert it to mass. So we say, if we have 100 grams of this stuff, then how much of each of these elements do we have? And that's really easy. 40.002% of 100 grams is 40.002 grams. You're literally just changing the percent sign to grams. Now, we do something slightly more difficult. We have to convert to moles, which means we divide by the molar mass of each element. 40.002 grams of carbon divided by 12.011 grams per mole means we have 3.3304 moles of carbon. 6.7142 grams of hydrogen divided by 1.008 grams per mole gives us 6.661 moles of hydrogen. And 53.2838 grams of oxygen divided by 15.999 grams per mole is 3.3304 moles of oxygen. Now remember, the last video ended by talking about the diatomic elements, and hydrogen and oxygen are among the diatomic elements, and how you have to be careful about the diatomic elements and so on. Well, this is one place where that can trip you up, because we're not talking about molecules of hydrogen and oxygen. We're not talking about the elements in their native state. We're talking about the elements as part of a compound. We're talking about individual atoms or moles of atoms rather than molecules or moles of molecules. That's why it's 1.008 rather than 2.016, 15.999 rather than 31.998. So now that we have our moles, we find the ratio. That means we just find the smallest number of moles, and we divide all of them by that number. So, the smallest number is 3.3304, so we divide all of them by that, and we have our ratio, 1 to 2 to 1. Our empirical formula for this particular example is CH2O. Remember, this is just the empirical formula, not the molecular formula. We don't yet know the molecular formula. We can get there soon enough. First, how about you do an example? Here is an unknown compound made of carbon, hydrogen, and nitrogen. Here's the percent. So why don't you go ahead, pause it, try to solve the problem. Okay, yeah, I know you're cheating. You didn't actually pause. But here's the mass. Easy thing. Okay, that was the easiest part. Now seriously, go back and try. Okay, fine. I'll go ahead and convert to moles for you. But now, try and find the ratio. God, you're the worst. Okay, here's the ratio. 5, 7, 1. The empirical formula for this particular example is C5H7N. So now, let's get from the empirical formula to the molecular formula. The last thing you need, the last bit of information you need to be able to get from the empirical formula to the molecular formula is the molar mass, or formula mass, of the compound. Then you compare the molar mass of the empirical formula to the molar mass of the actual molecule. Molar mass divided by empirical mass is going to give you a whole number. And that's how many times the empirical formula shows up in the molecular formula. Let's walk through an example. So the earlier example I walked through had an empirical formula of CH2O, and the molar mass of that compound is 180.16 grams per mole. To find the molecular formula, we find the mass of the empirical formula. CH2O is 12.001 times 1 plus 1.008 times 2 plus 15.999 times 1 gives us the empirical mass, or formula mass of the empirical formula, of 30.026 grams per mole. Now we divide one number by the other. The molar mass of the molecular formula divided by the molar mass of the empirical formula. 180.16 divided by 30.026 gives us 6. Okay, it's not exactly 6, it's like 6.00000026 or something like that. It's just rounding. It's going to be a whole number. Which means that the empirical formula, CH2O, shows up 6 times in the molecular formula. So 6 times CH2O gives us C6H12O6. That's the molecular formula of this compound. Sugar. I was just working with sugar. Now why don't you go ahead and give it a shot with the earlier example we did. The empirical formula C5H7N, the molar mass is actually 162.23 grams per mole. Given those 2 bits of data, what is the molecular formula of this compound? Seriously, go ahead, pause it, try to work it out for yourself. When you add it up, the mass of the empirical formula is going to be 81.118 grams per mole. 162.23 divided by 81.118 is going to give you a ratio of 2. The empirical formula shows up in the molecular formula twice. So you just multiply each of the subscripts by 2, giving you a molecular formula of C10H14N2. It was nicotine, by the way, if you're curious. And now, if you want, you can just go ahead and turn off the video here. This is a more direct way of getting from mass percent to the molecular formula, if you have the mass percentages and the molar mass. If you have that, you can go directly to the molecular formula. You don't need to go through the empirical formula. Here's how. You have the mass percentages as normal, but when you convert to mass, you don't say, what if I have 100 grams? You say, what if I have 1 mole? So, that would be 40.668% of 177.204 grams. 8.5325% of 177.204 grams. When you do that, you get these numbers. So that is the percentage of 1 mole of this substance that is made up of carbon, hydrogen, oxygen, or nitrogen. And then, just like before, you convert to moles. So 72.065 divided by 12.011, 15.120 divided by 1.008, etc. This will tell you how many moles of each element there are in 1 mole of the compound. Once again, this gives us nice whole numbers, once you account for rounding error. This is the molecular formula directly. You don't need to go through the empirical formula anymore. C6H15O3N3. This time, it's not based on a real compound. I just made this up entirely. But, it works every single time for any kind of compound, so long as you have the mass percentages of each element and the molar mass of the compound in question. So why don't you go ahead and give it a shot. Here's the mass percentages of some random thing I made up, and the molar mass. Okay. Here is the percent by mass of 1 mole, or percentages of 364.152. Then when you convert those to moles, and that gives you a molecular formula of C8H20N2P4O6. And finding empirical and molecular formulas is not, it is definitely, absolutely, by far not the only thing we're going to be using moles for. It's just a very, very good way to practice. That'll do it for this video. That'll do it for Chapter 2. Remember moles. Get good at working with them. Similarly, Avogadro's number. See you next time.